So as I mentioned before, when we talk of quasi experimental research or quasi experimental approach, we're actually talking about three types of quasi or quasi experimental approach. We have the time series, non-equivalent group design, and of course the counterbalance design. So several designs have been developed for these situations that are almost true. So that means if you cannot do true experimental research, then you might as well use quasi-experimental design, particularly time series, non-equivalent control group design, and the counterbalance design. So let's take a look at the time series design. In time series design, the researcher observes one group of subjects or participants repeatedly. So the cue here is, of course, the word repeatedly, both before and after the administration of the treatment. This can be done in a controlled experimental setting, but this particular design also lends itself well to a more naturalistic setting, particularly to the classroom setup if you are a teacher, which of course the data are commonly collected to the subjects or to the group of participants, and the researcher would be looking at the effects of some treatment or intervention which you did. Okay, so for example, if a researcher might examine the test scores of students at a given school, maybe for several years, both before and after the implementation of the given school days. So in this situation, the yearly test scores represent the time series data and the change of the scores to the extended school days. Okay, so this would be a natural occurring, and then we call it quasi-experimental treatment, particularly the time series design. Okay, this this approach or this type of experimental research, particularly under quasi-experimental research, is actually the improvement. No? It's the improvement of the single pre-post test design. See, it improves the pre-test post-test design, which of course when we consider the pre-test and post-test design, it's actually not in a long-term effects. For example, for a week, you would be considering a particular strategy. You would be using it, considering the competencies that you have identified in your curriculum. And then before the implementation of the intervention, of course, you will have the pretest. And then after that, after a week of using the intervention or a month of using intervention, then you will have your post test as compared to the time series design that can be further improved by, of course, you would be including control group, and that control group would be examined over time but does not experience the treatment. Does not experience the treatment. So that is what we call the multiple time series design. Here, what you need to do is to establish a baseline measure of subjects by administering a series of tests over time, then expose the group to the treatment, and then measure the subjects with other series of tests. That's time series design. As for the multiple time series design, you would be having a control group. Yan. Since there is no control group here in the first one, time series, not multiple time series, then one cannot determine the effects, okay, of history on the test scores because this is a long term, right? So therefore, you cannot determine the effects of it since there is no control group. As for the multiple time series design, if we would be identifying one group to be the control group, then you would be able to determine the effects of the intervention that will be done to the test scores of the students. And so instrumentation may also be a problem. So be very careful when you would be considering this as your research design. Are the tests equivalent or are the tests the same? So that's should be the first thing that should be considered. When you prepare tests or questionnaires, the items included should consider the competencies that you have identified. So when we say competencies, we're actually talking about the lessons that you are teaching. As for this time of the pandemic, we're actually talking about the most essential learning competencies. So in the preparation of the questionnaires or the tests, you have to make sure that the items are equivalent. No? For example, you would be implementing four similar tests, no? Equivalent tests, but not necessarily the same. But they are targeting one competency. So the particular competency, competency number one, you have to prepare for four questions considering the competency and make sure that those questions are not the same, no? But they are testing, of course, the particular competency. Yeah. In order for you to make sure that the students improve their score, not because of the same test. Because if, for example, you would be able to encounter the same test again and again, then you would be able to know immediately the correct answer. So make sure that it should be equivalent because there is a possibility that after taking the test for the second time or for the third time, they already knew the answer. Okay. So you have to be very careful when you do time series design. As for the non-equivalent, okay, control group design, the researcher will choose existing groups that appear similar. Okay, since randomization will not be done because this is quasi experimental research, you have to choose existing groups that for you, as a researcher appear similar. Don't forget appear similar. The characteristics, the normality of the population, the IQ, okay, then but only one of the groups experiences the treatment. Okay, so don't forget one of the groups. Okay, only one of the groups will experience the treatment. In comparing it with the true experimental design, with of course random assignment because it's true experimental research design, the control group and treatment groups are considered equivalent in every way other than the treatment. But in a quasi experimental research, the groups are not random. Again, the groups are not random. So therefore, they may differ in other ways because they are non-equivalent groups. That's why here, as you can see, the types of uh, quasi experimental research, we have here the first one, non-equivalent control group design, because no randomization should be done. So when using this kind of design or quasi experimental research, you have to take into consideration any confounding variables by controlling them in the analysis or by choosing groups that are similar as possible. Similar as possible. If, for example, in your school, you are considering homogeneous sectioning or heterogeneous sectioning, then that would be great. You would be able to know, the characteristics of the first group or the second group or the control group or the experimental group. in order for you to ensure the internal validity of your research. So you have to consider the confounding variables. If you fail to do that, then there is a possibility that the result may not actually reflect the actual relationship of the variables, because maybe one group belongs to one section, which is that section, if homogeneously sectioned, therefore it's that group is better than the other groups. Okay, so as you can see here, only one group receives the treatment. Okay, 0 1 x, then that x is the treatment, so they will be given pre-test, then the treatment, and then the post-test. So what's the difference again to the pre-test post-test design? In the pre-test post-test design, under true experimental research, randomization was done. But here in the non-equivalent control group design, there was no randomization. So this design should only be used when random assignment is impossible. Uh, if, for example, the administrators do not want you to resection, or the principals or the parents did not agree that their sons will be included into the experimental group. So that's the first thing that should be considered. It does not control for self-maturation, interaction, statistical regression, and then pretest sensitization. I'll be discussing these terms now when we discuss internal and external validity. So as for counterbalance design, subjects are not randomly selected. So again, not randomly selected because part of the Quasi Experimental Research, but are used in intact group. Intact group. Group 1 receives treatment 1 and test 1. Then at latter time, they receive treatment 2 and test 2. So group 2 receives treatment 2 first, and then treatment 1. So as you can see here in the presentation. So group 1 will have the treatment, okay? And then test, and then treatment number 2, and then another test will be given. So counterbalance design. This actually is a procedure that allow you as the researcher to control the effects of nuisance variables in designs where the same participants are repeatedly subjected to the treatment or to the intervention that you would be using. So counterbalancing means here that systematic variation of the order of the phenomenon in the study or the conditions in the study that will enhance the research internal validity or the study's internal validity. Of course, in the context of experimental design, but focusing on the quasi-experimental design, and the participants are not randomly selected. For example, two third grade classes received two special studies on language, one in classroom and the other on a computer. So class 1 does the classroom work first, followed by the computer. Then class 2 does the computer work first, and then both groups are tested after both treatments. Okay. So as for the analysis of the data that you would be able to gather from the two groups, you would be using Latin square analysis. Since randomization is not used again in this design, selection maturation interaction may be a problem. So one of the threats to the validity of the research is, of course, selection, maturation, interaction. So that's it for quasi experimental research. We'll try to take a look at the, I'll just stop presenting, the threats to internal validity in order for us to understand more the discussion. I'll just take a look at my presentation. Threats to internal and external validity. So these are the internal um, threats to the validity. We have the history, maturation, testing, instrumentation, statistical regression, differential selection, experimental mortality, selection, maturation, interaction, and the John Henry effect and experimental treatment diffusion. Let's discuss each of the threats to internal validity of your research. So for history, this actually refers to the events other than the treatment that occur during the course of an experiment, which may influence the post-treatment measure of the treatment effect. Okay, it's actually another event that will affect not because of the intervention.
Sorry, Doc. Doc, sorry to interrupt, but
Yes.
do you share? We can't see your screen po.
I'm sorry. I'm not sharing. I'm sorry. Thank you for
It's
telling me.
okay.
Can you see it now?
Yes po.
Yes po.
Yes, Doc. Nakikita na po.
Thank you.
Yes po, Doc.
So again, no, this is the first one. History, and that would be part of the considering, no, the threats of to the internal validity. So when we say internal validity, we're actually talking about the whether the experimental or the intervention or the treatment that you did really made the difference to the performance of the students, or there are other factors that made the performance of the students difference. Okay, if there is really a significant difference, or is there a sufficient evidence to support your claim that the performance of the students became high because of the intervention that was done and not because of other factors. So that's what we call internal validity. As for the external validity, later on when we discuss, we're actually talking about the generalizability of the treatment, okay, or the intervention that you did in order for your students to master the lesson. Okay, so hopefully internal validity is very clear and external validity is very clear. Okay, again, I would like to reiterate, when we say internal validity, we're actually talking about whether the intervention that you did or the experimentation that you did, the strategy that you used, really made the difference to the performance of the students. Okay, whether there is a sufficient evidence to support your claim as a researcher. And for external validity, we're actually talking about the generalizability of the treatment. Okay, for first factor, which of course could jeopardize the internal validity, is the history. No? The specific events which occur between the first and then second measurement, 'di ba? At the start, when we are having experimental research, we have the pre-test, right? And then we will have the intervention or the treatment. And then after the intervention or the treatment, we'll have the post-test. So, history. So that means what are the other things after and during and then before the testing, what are the things happened to the students? Maybe there are factors like there is a problem because in this time of the pandemic, the family of the particular student uh, or family member uh, tested positive in COVID. So there is a possibility that the students will not perform well during the post test because of what happened to his or her family. So there is a specific event that happened in between the first and then the second treatment, which is not because of the treatment or the intervention that you use, but because of the that particular event that happened to your participant. So that is history. Maturation. Subjects change over the course of an experiment. So when we say subject here, we are actually talking about our participants. Okay, the participants of the research. There is a possibility that at the start, the students or the participants are not yet mature enough to do the particular experiment. Then eventually, they matured, particularly if you would be having time series design for a long period of time, then the performance of the students improve. And not because of the treatment, but because he is already mature. Or sometimes at the start, no, during the pre-test, they don't care. No, they don't care. They did not answer properly the questions included in the questionnaire. Then eventually, during the post-test, because they realize the importance of the experimental research that you are doing, then they answered the questionnaires properly. So that could be maturation. So these are some of the things that can jeopardize the internal validity of your research. So we have to take a look now. Next, testing. As I mentioned a while ago, no, a common research design is to give a group a pre-test, treatment, and then post-test. So there is a possibility that when you include items that are the same, then maybe the students would be able to get the correct answer during the post-test because they already knew the answer to the particular question because it has been conducted during the pre-tests. Okay? So it is not anymore because of the treatment, but because they already knew the answer to the question. So I would like to encourage you to make sure that the items included in the pre-test and the post-test are not the same. It should be equivalent tests. Okay. Are you still with me? Can you hear
Yes,
Yes,
me?
Doc.
Doc.
Yes, po.
Okay.
Yes, sir.
Yes.
Yes po.
Yes, Doc.
Okay, thank you. So
Yes po.
we're actually talking here about the effects of taking the test. Just like us, di ba? If we were able to encounter a particular question, then for the second time that we would be able to encounter that the same question, then we would be able to answer it correctly. So we have to avoid that, particularly when we do experimental research. Okay? If you use different tests, so it's somewhat related to testing. No? If you use different tests for pre and post measurements, then the change in pre and post scores may be due to the differences between the tests. rather than the treatments. Okay, so it's because of the changes in the instrument or the scores, which may produce changes in the outcomes and not because of the treatment. So make sure that the tests are equivalent. So that's actually my suggestion for the testing and then instrumentation. Because if it is different, there is a possibility that they would not be able to get the correct answer, and it may affect the performance of the students. As for the statistical regression, uh, here we're actually talking about the tendency of the extreme scores. When we say extreme scores, those who got very high at the start, no, yung during the pretest, and very low during the pretest, to move towards the average on a second testing. So maybe because of maturation, because they are not serious yet, that's why they they fall under the extremes in the normal curve or outlier. When we say outlier, for example, out of 20 items, there is a particular student who got 0 or 1 only out of 20 item test. So that would become outlier, which is different from extreme, no? Extreme scores. So there is a possibility that those students who got very low will move towards the average or maybe will get a very high score. So that's good. That's good, no? Because after conducting the intervention or the experimentation, maybe because of the intervention that you did, they were able to understand the lesson. So those who got very low move, no, to the average or even to high scores. So that's good because there will be significant difference in the performance of the students. But the concern here is this: if the students who got a very high score, or the students who got high scores, will tend to get low score during the post test, then there is something wrong. Statistical regression, differential selection. We're actually talking here about if we select groups for treatment and control differently, then the results may be due to the differences between groups before treatment. That's why when you select groups, very important, no, if they will allow you to use randomization, then be happy because you would be able to consider this threat to the internal validity. So therefore, when you use a particular strategy in choosing control group, then you will use the same strategy in using the experimental group. Do not differentiate. So that's differential selection. But usually, uh, we call this also selection of subjects, selection of subjects or selection of participants. If you will not use randomization, consider first whether the groups are sectioned homogeneously or heterogeneously. Then you set the criteria. But if they will allow you to use randomization or random assignment, then better. Experimental mortality. Here, the loss of subjects or the loss of participants for maybe a very valid reason. If, for example, you started the experimental research, you have 50 students, then eventually, because of concerns, they can't continue anymore with their schooling or their studies, then it will affect the result of your research. Selection maturation, interaction of subjects. So interaction means the mixing or combining of separate elements. If you draw a group of subjects from one school to serve as the treatment group and a second group from another different school to serve as a control, so you could well find beyond the simple problem of selection differences because maybe the groups are not equivalent. There is a possibility that the first group would be performing well because they are really better than those who are in the second group. So it would be better that if you choose or you select your participants, use one school for experimental research and not two different schools. And finally, the John Henry effect. The legendary driving, if you know the story of this, set himself to prove that he could drive railroad spikes faster and better than the newly invented steam. Here, we're actually talking about the control group and the experimental group. If, for example, the control group found out that you are going to compare their performance, no, to the experimental group, and because they are self-motivated, they want to perform better compared to the experimental group, then the result of your research would be affected. Okay? There will be no significant difference in the performance of the experimental group, even if the intervention or the treatment is really effective. But because of the subjects or the participants included in the control group, they perform well because they want to be better compared to the experimental group, then that would affect your research, the internal validity of your research. There will be no significant difference, not because of the treatment, but because the control group would like to perform more because they are motivated that when they would be compared to the experimental group, they would be better. Ah. So John Henry here was actually a worker who outperformed a machine under an experimental setting because to take note, he was aware that his performance will be compared to that machine. Now, if the control group, if aware that they will be compared to the experimental group and they want to be better than the participants in the experimental group, then the result will be affected. Okay? It will jeopardize the internal validity of your research. So those are the factors that can jeopardize the internal validity or threats to internal validity of your research. So again, we have the history, maturation, testing, instrumentation, statistical regression, selection of subjects, experimental mortality, selection, maturation, interaction, and the John Henry effect. Okay. Take note, next week we will have the first quiz. Then all the things that I discussed would be the content of the first quiz. Okay, 30 to 40 items. Don't worry, no. It's just like a recall test. You just take a look at the PowerPoint presentation. I will be uploading all the presentation today. And I will also be uploading an example of experimental research for your reference. Okay. We have one more, no? Similar to treatment diffusion, similar to John Henry effect. If subjects in the control group perceive the treatment as very desirable, they may try to find out what's being done. Okay. Then next, we'll have the threats to external validity. So what is again external validity? We're actually talking about the generalizability of the treatment, okay? Or the outcomes, generalizability of the outcomes, no, of your research. So that means a particular treatment or strategy is effective to this particular group, then therefore it could be generalized that it will also be effective to the other groups, no, if you were able to choose the sample properly, considering the sampling technique. Okay. Reactives effects of testing. Subjects in your samples may respond differently to experimental treatments merely because they are being tested. Since the population at large is not tested, experimental effect may be due to the testing procedures rather than the treatment itself. Okay, so this reduces generalizability, which means we cannot generalize that the treatment could also be effective to the population. So again, the population is actually the totality of the subjects that can be used for the treatment, no, for the experimental group. But you did not include them because you only choose sample that will represent the population. So as you can see, one type of reactive effect is pre-test sensitization. Another type of reactive is post-test sensitization. So the post-test can be in itself a learning experience that helps subjects to put at all the pieces together. No? Different results would be obtained if the treatment were given without a post-test. While a researcher must make measurements, care must be taken to measure treatment effect, not to add to it with the post-test. As you can see in your assessment, in assessment, we have the so-called assessment for learning, assessment as learning, and assessment for learning. So there is a possibility that while taking tests, they are already learning, not because of the treatment, but because of the tests being provided. Okay, so make sure that the summative test or the test that will be included in your pre and post tests are not types of tests na test for us learning. No? It should be assessment of learning. You are trying to assess the learnings of the students based on the lessons being discussed. Okay. So don't forget the different types of assessment. No? Assessment as learning, for learning, of learning. So the type of test that should be included in the pre-test and post-test should be assessment of learning. Hopefully your measurement and evaluation teacher was able to discuss with you the different types of assessment. Assessment as learning, of learning, for learning. So I was actually teaching measurement and evaluation before. But since I'm handling two sections already for methods of research, it would be very difficult for me to have another subject or another section because I'm actually checking a lot, no, a lot of researches, reflection papers. And so if you can't understand it yet, you might want to read about assessment of learning as learning and for learning. Treatment and subject interaction. So treatment, that would be the intervention. And then as for the subject interaction, we are actually talking about the interactions of the participants. So subjects in a sample may react to the experimental treatment in ways that are hard to predict. So this limits the ability of the researcher to generalize findings outside the experiment itself. If there is a systematic bias in a sample, then treatment effects may be different when applied to a different sample considering the population. So it cannot be generalized again to the population. It will only be true to the sample who were included in the experimental group. And then testing and subject interaction. Subjects in a sample may react to the process of testing in ways that are hard to predict. Just the same, considering the testing. This limits the ability of the researcher to generalize findings again outside the experiment itself. So it will be only be true to the sample taken from the population. So to the participants included in the experimental group. And finally, multiple treatment effect. Normally, we find a single treatment. So when we do experimental research, you have to make sure no, that there should only be one treatment. No, that's my suggestion since you are still starting. Eventually, if you are already very familiar with experimental research, then you can make use of multiple treatment. But this would be very difficult at the start. So if, however, an experiment exposes subjects to say three treatments, no, not only to a particular strategy, so there will be three strategies. The concern here, we would not be able to determine whether treatment A or treatment B or treatment C made the performance of the students better. Okay, so it may have been the combination of the treatments. Okay, it may have been the combination of A and B only, or B and C only, or the combination of the three treatments. So that would really affect the generalizability of your research. You cannot say that treatment A made the difference only because there is a possibility it's actually the combination of A and B.